What's going on, guys? It's Stephen here from Digital Renovations. Don't forget to like, share, subscribe, hit the little bell icon, and point randomly at the nearest doorway in the hopes of catching someone off guard as they awkwardly enter the room, if you want to help me out here and stay up to date with the latest videos at Digital Renovations. Today we're going to be taking a look at Docker networking. In the world of Docker, there's a few different types of networking that you can leverage to get the right setup. Today we're going to be focusing on the bridge networks that are available to you. In Docker, a bridge network is designed so that you can connect your bridge network with your host network easily by exposing ports between both networks. When you create a Docker container, it is actually already connected to a Docker bridge by default. Docker has one ready, and it'll just start assigning IP addresses that are isolated from your home network. Unless, of course, you choose to publish or expose ports between the two networks. So let's dig a bit deeper into that. The first type of bridge we're going to look at is the default bridge. The default bridge is our default network option. Shocker. Yeah, that's right, network's out of the box. Boom! When new containers are spun up, they connect by default to the default network bridge. Even before you have containers up and running, Docker has the default network set up. If we jump into PowerShell and type docker network list, ls, hit enter, you get a list of networks, and one of them you'll see that has a driver type, or network type, of bridge. Creatively, they've decided to give it the name bridge also. This is our default option. So if we start creating containers, so docker run itd name proxy, and we'll use ngin-x, and docker run -itd -name, call this one server, and we use Alpine, and then we go docker inspect bridge, because the default network's name is bridge, enter, and here we get a heap of information about that network. But we want to look over here specifically, and we can see that those two containers, proxy and server, each have IP addresses associated with them within the default subnet. We can even log into the server. We'll run docker exec it server sh shell and just ping our proxy server by going ping 172.17.0.2 from our container IP address above. And we can see that it's responding to us across our network, which is cool. But if we wanted even more control, what if we wanted multiple networks? What if we wanted a built-in DNS? Let's create what's known as a user-defined bridge. So we're going to do that by typing docker network create. We'll call this one DigiRenos for Digital Renovations. Hit enter. Boom, it's up. Now if we check our list of networks, docker network ls for list. It helps if we spell things correctly. Let's go with docker network ls, hit enter. Now we can see that we've got our bridge still, but we've also got DigiRenos set up with the driver type of bridge. So let's add some containers to it. Let's go docker run itd, and we're going to specify a network, DigiRenos, a name, server, we'll use Alpine again. Because we've already used the container name server, we're not able to use it again. So let's quickly docker container stop server, docker container stop proxy, docker container prune to get rid of the stopped containers, and try that again. Perfect. Now we have that created. Let's do our proxy again. Docker run ITD, network, digi-renos, name, proxy, and we'll use ngin-x again. Perfect, now that's up. Let's go docker, inspect, digi-renos. Perfect, now we can see our new network. We've got a subnet of 172.18.0.0, and we can see that we've got .2 here as our server and .3 as our proxy. Perfect. So let's jump in and have a play. Let's go docker, exec, IT server, shell. Now once again, we can still ping our proxy with 172.18.0.3. But now, with the user-defined bridge network, we're also able to just say ping proxy. And it works just like that. We've got a handy-dandy little built-in DNS to keep things moving for us. This can come in super handy if you're building, rebuilding, starting, stopping, because IP addresses can be refreshed and set to new addresses, but by leveraging the name field, you will still be able to connect with the device, as the DNS will resolve the new IP address for you. Alright. So what if we create a second network now? Docker, network, create, media. And let's add to that docker, run, ITD, network, media. We'll call this one Jelly and install Jellfish onto it. Let's also, just for the fun of it, install BusyBox. Excellent, alright. So let's take a look at our network. If we go docker, network, list, we can see that we've got a new media network down here with type of bridge. If we go docker, network, inspect, digi-renos, we can see that we're operating on the subnet 172.18.0.0. If we go docker, network, inspect, media, we're running on the subnet 172.19.0.0. So if we go docker, exec, it, -it into our new BusyBox using shell, and we decide to ping the server we created earlier, ping server. Waiting. Nope. Doesn't know how to resolve server with the DNS. What if we try the IP address? IP address for server 172.18.0.2. 172.18.0.2. Hit enter. And it's trying to ping, but it's not getting anything back. Now it's happening because our networks are completely isolated from one another, which is fantastic from a security standpoint. So now let's say we want to build a media library accessible via Nginx reverse proxy, and we want to set it up with Docker Compose. We'll exit from here and start fresh. Let's take a look at a Docker Compose file that I've already set up for this. Alright, so in our Docker Compose file, aside from our services, which we normally set up, we've also got a network section. So we're going to create a network, we're going to give it the name media, and the driver type is bridge. So the network type is bridge. Then within each of our services, we've got Jellfish, because it's a media server, with a network of media. Same deal for our reverse proxy. We're putting it on the media network. And that's all it takes. So if we jump back into our shell and we go with docker compose up -d, we'll hit enter. It's going to run through and create those for us. We now go docker network list. We can see that we now have Docker Networks media set up. And if we inspect that with docker inspect Docker Networks media, we can see that we've got our Jellfish and our Nginx set up here as containers on the network, running happily away. That's it for today. We'll be covering the other types of networks available in Docker at a later point. Till then, don't forget to like, share, subscribe if you found this helpful. And until next time, have a good one.